ever-looming threat of destructive earthquakes is the thing so many nations have to deal with. Countries like Japan, the United States, and Taiwan are especially affected by this, being struck by thousands of earthquakes annually due to their respective geographic locations. When the threat is so big, preparations are needed to prevent catastrophe. But some regions continuously fail to take these precautions against the incoming disaster. Thankfully, there are a number of ways to decrease the effects of an earthquake, and each country deals with the threat in distinct ways that we can learn from. This is Iconic Builds, and today we are going to take a look at 3 different structures from 3 different countries which deal with the threat of earthquakes in their own way. Tokyo Skytree. Situated right on the infamous Ring of Fire, Japan has a history of disastrous earthquakes and tsunamis following them. Because earthquakes are such a common occurrence, the Japanese government has been taking the necessary measures to prevent the damage by building structures that are specifically designed to withstand earthquakes, rebuilding certain buildings when needed, and even passing laws that limit the size of skyscrapers. The tallest structure in Japan, the Tokyo Skytree Tower, is a textbook example of how the Japanese engineers deal with the constant threat of earthquakes by applying the most creative solutions. Tokyo Skytree has conventional qualities that make a tower earthquake-resistant, like exceptionally strong and rigid steel tubes at its base. But what makes this tower special is in the center. Inspired by traditional 5-story pagoda designs in Japan's history, engineers built a central column in the tower that is not attached to the rest of the tower. This column acts as a counterweight during an earthquake and shakes independently from the tower, counteracting the impact of seismic waves. Utah State Capitol. While the Japanese build everything with earthquakes in mind, the story of the Utah State Capitol is a bit different. When it was built in the 1910s, financial limitations prevented the government from building the structure according to Richard Kletting's original design. A study later revealed that the Utah State Capitol was vulnerable even to moderate earthquakes, proving that the building was in dire need of renovations. Almost 100 years after its completion, the building's foundation was removed completely. To make sure it could withstand an earthquake, engineers first isolated the structure from its base. A new concrete mat was poured, and a total of 280 base isolators were installed over this mat, just under the original support columns. The isolators, made from layers of laminated rubber, ensure the building will rock more gently in case of an earthquake. The renovation of the Utah State Capitol building cost a total of $260 million in 2008 and proved something very important. Earthquake-proofing buildings retroactively is a possibility, even if the original structure was faulty. Taipei 101. We already covered this colossal building in another episode, but we never got deep into what makes it so resistant to earthquakes. Also located near the dreaded Ring of Fire, Taiwan gets its fair share of earthquakes. There are currently 42 active fault lines in the country, and the east coast of the country goes through countless earthquakes. The world's tallest building from 2004 to 2009, Taipei 101, is equipped with several precautions that make the building especially durable. It is said that the building can withstand the strongest earthquakes in a 2,500-year cycle. The skyscraper's high resistance against earthquakes comes from a mix of flexibility and a solid foundation. To prevent structural damage, the building is able to sway with earthquakes and even typhoons. 380 piles, each driven 80 meters into the ground, create a rock-steady foundation. But maybe the most interesting feature of this building is the 660-ton pendulum hanging from the 92nd floor. Like the central column of Tokyo Skytree, the pendulum's out-of-phase motion creates an inertial force that abates the resonant vibrations caused by winds and earthquakes, reducing the impact of these forces on the building. Ingenuity of engineers created a number of ways to minimize the damage caused by natural disasters. Foresight and responsible budgeting play a huge factor in using their discoveries to save lives. We can't stop earthquakes. Sooner or later, they will come. So the only thing we can do is be prepared when the inevitable comes.